Okay, good morning. We're going to be talking about weather services today, aviation weather services. And I want to start out by talking about maybe the most vague FAR 91103 that's out there. Each person in command shall, before beginning a flight, become familiar with all available information concerning that flight. Okay, and part of that is all available information, or the information must include for a flight not in the vicinity of the airport, weather reports and forecast, right? Fuel requirements, alternatives available, if the planned flight cannot be completed, and any known traffic delays which the pilot in command has been advised by ATC. But as far as weather, it basically just says weather reports and forecasts. So what does that mean? That's what we're going to be talking about today. What are we going to do about weather reports and forecasts? So throughout the U.S., really throughout the world, but throughout the U.S., there are systems of observations that occur. Maddie, there's seats. There's one here if you want to sit. You okay there? Okay. There are different ways in which we gather weather information, and we develop observations and forecasts for pilots' use, and that's what we're going to talk about today. How many of you went to the FA's, or not the FA, yeah, the FA site, 800wxbrief.com, and made an account? Does everybody have an account there? Okay. So in the last part of the class today, we're going to spend all of our time just in that website, showing you how to get around in there, what to do, things to do there. But first, let's just talk about weather, how we get it. Last week we talked about weather theory. This week we're talking about the reports that you can get, how they come about, how they get disseminated, and that type of stuff. All right. So first of all, I want to talk about observations. How do we get this information that we put down on paper or that we put out on the websites, the National Weather Service distributes or disseminates out to us? Where does it come from? Okay. So it comes from really four ways. We get surface observation, or at least from an observation standpoint. We get surface observations, we get upper air observations, radar observations, and satellite observations. So through those means, the meteorologists then take that information and produce all the weather reports that we're going to be looking at today. So let's go through these, first through the surface observations and what those are. And you're going to be familiar with this, the surface observation. It's basically the METARs, right? Everybody here knows what a METAR is, right? Anybody not know what a METAR is? Everyone that's flying out of here, before you fly, when you listen to ATIS, you're getting the METAR, right? That's what you're listening to, is the METAR. So METAR is a compilation of elements of the current weather at individual specific ground stations, usually at airports, but not always at airports, but you'll find them at airports quite a bit. They could be in the form of ATIS, which you'll find at towered airports or where the tower is operating, AWOS or ASOS, which would be at non-towered airports or other facilities that provide weather. Kevin, there's a seat here and there's a seat here. That one's going to be tight for you. You're a big guy. That one might work. So AWOS and ASOS, you'll find those at non-towered airports. Air route traffic control centers that are located throughout the United States, not necessarily anywhere near an airport. They could be, but not necessarily anywhere near an airport. Those will have weather reporting capabilities as well. So that's where we get the surface observations. Upper air observations are basically two methods. One is balloons. We send up balloons, I think every 12 hours. If I remember correctly, I think it's at 0 Zulu and 1200 Zulu or something like that. Anyway, those go up every, twice a day. And then we get pilot weather reports from guys flying. So that's where the upper air reports come from. Radar observations. Different types of radar, NEXRAD radar, commonly called Doppler radar. Everybody's heard that term before. FA terminal Doppler weather radar. Airport surveillance radar, and then airborne radar are different ways that we can get radar observations. Okay, so you can get some upper air stuff from the radar as well. Then we have satellite observations. So satellite products will give you our significant meteorologic information. SIGMETs, we'll talk more about those as we go along. And AirMets, we'll talk about those as well. Everybody here should be familiar with those. Anybody not familiar with SIGMETs and AirMets yet? In your training? Not familiar with those? Okay, we'll go over those today. SIGMETs and AirMets. Okay, then we have something called service outlets that we're going to talk about a little bit. Not a little bit, a lot. Service outlets are things like the Automated Flight Service Stations, or FSS. So how many of you are at or have gone through cross-country flight training or in that stage now where you've contacted flight service? Anybody ever talked to flight service? Okay. Anybody ever gone to 800wxbrief.com and got a weather briefing? You haven't done that yet? You're in cross-country training?
Just this week.
You're just starting. Okay, you're just starting. Okay, all right. All right, so when you get to the cross-country training, this is where this kind of stuff, where this rubber hits the runway right here in the cross-country training. You have to be able to get information regarding the weather as to current weather, what's the current weather doing, what's the forecast weather doing, and we're really getting that primarily from flight service stations, from FSS. Okay, so a couple of ways to do that. You can log into their website, which is what we're going to do today, 1-800-WXBrief.com, or you could call them. You can pick up the phone and call 1-800-WXBrief, and you'll be connected to a weather briefer. Okay, it used to be that weather briefers, flight service used to be located at airports. So, and this wasn't that long ago. When I started flying, it was certainly that way. There was no internet. The flight service stations, for instance, the flight service station that takes care of us in this area is which one? Who knows? What flight service? San Angelo. It's San Angelo. So San Angelo is quite a ways from here, but in San Angelo there was a building, a physical building, where you had meteorologists and flight service specialists that worked in this building. And in my experience, those buildings were always brick buildings with no windows, and they were telling us what the weather was, but that's what it was. You could fly in there, and you could walk over to this building, and you could get a weather briefing, and a man or woman would get the charts out and show you the weather and show you what was happening, and you tell them where you're going, and they'd give you a weather briefing in person right there on the spot. That all changed, and it's all become primarily based out of Washington State, I believe, is where they're based out of. So now when you call a flight service specialist, you're typically talking to someone that is nowhere near San Angelo, or wherever in the country you are. The person you're talking to, unless you happen to be up in Washington there, is nowhere near where you are. But with technology, they don't really need to be. They can get all the information they need, then give you the weather briefing from wherever they are. So when you call, because of where you're calling from and the phone towers that you're hitting, the system knows essentially where you are and what state you're in, and then you're directed to a briefer based on that. And depending on the state you're in, you may get a question like, are you in this part of Texas or that part of Texas, whatever the case may be, and then you'll hit 1 or 2 or whatever. You'll get directed to the proper briefer. At any rate, I'll talk more about using and talking to briefers when we get into the site, okay? It's important when you start learning this stuff, I feel like anyway, in my opinion, it's important that you self-brief and then you call a briefer and have them brief you on what you just self-briefed. It helps understanding, it helps kind of deepen the understanding of what you're learning, okay? Well, I'll show you how to do that. All right, and then pre-flight weather briefings, you get the briefings from them, and you can also, you can do it on the ground, you can do it while you're in flight. You can also file your flight plans with flight service. In fact, that's who you file them with. Whether it's a VFR flight plan or an IFR flight plan, you file it through the flight service station. where it goes from there depends on whether it's VFR or IFR. All right, a couple of different types of briefings, and in your, everybody that's got a binder, if you go to tab 10 on your binder, and somewhere in there you're going to find this 3-page document, or I guess it'd be 7-page document or 5-page document. All right, and this is I took it from this AC. I took it out of the back of AC 9092. So AC 9092 is designed or is a kind of a checklist and instructions on how to self-brief. All right, believe it or not, the FAA wants pilots to learn how to brief themselves. How many of you here are meteorologists? Okay, neither am I. But the FAA wants us to learn enough about the weather and about these weather services that we can brief ourselves and understand what the weather is before we go fly. And this AC 9092 is designed to help you do that. In the back of that AC is where I took this from. Okay? And it basically goes through the different types of briefings: Outlook, standard, and abbreviated. And then it has a checklist, a pre-flight checklist from a weather standpoint and we'll go through this when I get to the website, but a checklist on things to look for. I see people looking. Do you not all have this? You don't all have this? And under tab 10? Okay. All right. I'll have, at the break, I'll have Sebastian run some copies so everybody gets one. All right, so let's kind of look at these briefings just real quick and what they mean. There's 3 types of briefings. The first one, in the order that you would kind of do them, the first one that you would get would be an Outlook briefing. And an Outlook briefing would be, and this is where you're self-briefing. You're either going to 800wxbrief.com and you're doing this yourself, and you can put your planned route in and your estimated time of departure and all that kind of stuff. And it'll give you a briefing, okay, either in web format, or you can PDF it and you can download it and all that kind of stuff, print it out, whatever you want to do. But these are designed for if your flight is farther out than 6 hours and not farther out than 2 days. So 6 to 48 hours essentially is what you're looking for on an Outlook briefing. Beyond 48 hours, you're really not going to get anything that's really too useful. I'll talk about how to look at a flight that may be a week out. There's not really a briefing that's going to do that. You could call a briefer, but there's not a standard briefing that would give you that information. You're really looking at big picture stuff when you're looking that far out. But if you're within 48 hours, you can get an Outlook briefing. It'll give you some decent information. Okay. It can influence the decision regarding the route of flight, altitude, and ultimately the go, no-go decision. Understand something about weather, and I think I may have talked about it last week. Forecast, the closer you are to the forecast time, the more you can trust it, right? The farther out that forecast is, obviously, this goes without saying, right? The less weight you want to put on it, okay? So when you get an Outlook briefing, and you're looking at something 48 hours away, pour a lot of salt on that. Don't just take it at face value, all right? So what you might be able to get out of an Outlook briefing is a no-go decision, but it's unlikely you're going to get a go decision out of an Outlook briefing. Does that make sense? You may see, a weather system that's coming in that's absolutely going to tell you, this is an absolute no-go. And you may know that 2 days ahead of time. But what you're not going to know 2 days ahead of time typically is absolute go, right? All right. The next type of briefing is a standard weather briefing. And this is the typical briefing that we'll get when our flight is, within 6 hours of departure. So you typically want to get this the day of your flight, right, before you go. And they will always come out kind of in this order, whether you call them on the phone or whether you get a briefing, an online briefing, and have it printed out, web-based or PDF-based or whatever. You're going to get things in this order: adverse conditions. If it's on the phone, if you're on the phone, you'll get VFR flight not recommended if it's not recommended, but you'll only get that if it's a phone briefing, okay? And the reason they do that is because depending on the length of your flight, the length of your route, the briefing can be quite lengthy. You know, if it's a 50-mile flight, it may not be a very long briefing, but if you're going to, you know, Miami, there's a lot of stuff that they're going to be covering, all right? So what the briefer doesn't want to do is spend a half an hour on the phone with you and then at the very end say, oh, by the way, VFR flight's not recommended. So they want to say that right off the bat, right? So they're going to give you adverse conditions and they're going to say, because of this, VFR flight's not recommended. And then it's your decision to say, well, go ahead and give me the rest of the briefing, or okay, I'm not going to go, or whatever. So they're giving you an out right here. Okay. All right, then you'll get a synopsis, which is kind of a big picture thing, current conditions, departure, en route, and these are all forecast, destination, winds, temperature, loss, any notices that you need to know about at your departure and your destination, airports, any ATC delays or other information, all right? This is the standard format that this information comes out in. When we do it on 800wxbrief.com, you'll see on the left panel, it's laid out like this, and you can scroll through the whole thing, or you can click, let me go to here, let me go to here. You can click back and forth and look at those individual pieces, but it's laid out in that fashion. Okay, then the last briefing that you get is an abbreviated briefing. And the abbreviated briefing is designed, let's say that you get up in the morning of your flight and you make the call, you get your briefing, and your planned flight's 4 hours from now. Well, 4 hours from now, just before you go, you get an abbreviated briefing. And what you're doing here is you're checking to see what changed. Have there been any big changes from the standard briefing to now, so that you can tweak your plan if you need to tweak your plan, okay? So you have your outlook briefing, 6 to 48 hours, your standard briefing within 6 hours, and then your abbreviated briefing just prior to the actual flight, okay? Those are the briefing types. Okay, what is it we have to look at? Let's talk about that. So 91-103 says we're responsible for checking all the related information for the flight. And when it comes to weather, it says current forecast weather conditions. So what does that mean? And what is it we have to check? And how do we prove we checked it? And all those kind of questions. Well, what we have to check is current and forecast conditions in 3 places. Our departure, along our route of flight, and at our destination, okay? So our departure airport, what are the current forecast conditions at our departure airport? What are the current forecast conditions at airports along our route? You know, if it's a short route, you may only have a couple of airports that are along that route that you need to look at. If it's a long route, there's going to be a lot of airports. They're going to come up in the report. METARs and TAFs along the route, and then your destination, current forecast conditions at your destination, and then obviously at any alternates if you have to file. As VFR, filing VFR or flying VFR, there are no requirements. You don't have to file for alternates at all. There's no requirement for alternates. It only comes in if you're flying IFR under certain conditions. So for VFR, you don't have to file, you don't have to legally be worried about any alternate airports, legally. Now, practically, maybe you should be looking at alternate airports, but legally you don't have to look at alternate airports. But if you're looking at alternate airports, you obviously want to look at current forecast conditions at those airports as well. All right? All right, so what do we look at? This is where we have to start learning how to brief and what we're looking at. So what are we going to look at for current conditions? What's the first thing that comes to mind? What's that?
Cloud cover.
Cloud cover, okay. Yeah, you could look at cloud cover. What about a report? What kind of report do we get every time we fly? We get a METAR. METAR. METARs is a report of current conditions as of a specific time. They come out every hour, usually about 10 minutes before the hour, and they look like that. Okay, that's an aviation routine weather report. That's a METAR. All right, they come out in this format. And this is what you guys are used to hearing on ATIS. Now, if you haven't read a METAR or seen a printed METAR, this is what you'll see. And we're going to go through a bunch of these today in real time on a weather chart, and we'll start just reading some stuff out there. But they are laid out like this. It tells you it's a METAR. It gives you the station identifier, the time, the 16th day of the month, in this case, 1753 Zulu. It's an automated report. Winds are 140 at 21, gusting at 26. 3/4 statute miles visibility. Heavy thunderstorms with rain, mist, broken at 800, overcast at 1200 with cumulonimbus clouds. Temperature 18, dew point 17, altimeter 29.7. Remarks, pressure falling rapidly. Okay, so that's an example of a METAR.
It's a bad day.
This is not good conditions at this airport. Where GGG? That's here in Texas somewhere. GGG. Anyway, so this is the layout of a METAR. There's two ways that you can read, and when you take your check ride, your examiner is going to probably have you read a METAR in this coded format. Okay, so, and I get asked this question all the time: why do we have to learn? Why do we have to know this when you can so easily print it out, you know, in plain language? And that's really a good question. I think the biggest reason is this: when you're looking at a bunch of METARs, once you learn how to read this, when you're looking at a bunch of METARs, if this were spelled out in plain language, it'd be like 5 sentences worth of stuff. And it just takes a long time to read. It takes up a lot of space on the report. So it is much quicker and easier once you learn how to read it like this, all right? But I'll show you when we get to this wxbrief.com, there's a little button, radio button you can click, and you can go back and forth between coded and plain language, and you can learn how to read it that way. You can have it pop back and forth, and you can figure out how you read this stuff. There's some of these descriptors like baby rain, that's mist, baby rain, right? Some of these, there's some that I have to look up sometimes that you don't see very often. But you can go to keys to find what they mean if you don't understand what they mean. All right, so that's a METAR. Then we have pilot reports. This is another type of current, and so current doesn't mean that it's current right now. Current means it was current as of the time the time on the report. So just like I said, when you look at a forecast, if the forecast, you know, depending on how far out the forecast goes, the farther out it goes, the less you can depend on it. When you look at a current report, the farther back it was reported, the less you want to believe it. Okay, so you want to look at the same thing. So this is an example of a PIREP, pilot report. And these come in the type of report. So this is just your standard or routine report. The location, so like over is the way I think about that. It's over. This is my location, and this is the GGG VOR in this case. The 090 radial, 25 miles off of the 090 radial. So east of GGG, 25 miles. Okay. And then the time is 1450, and then this is the flight level, so they're at 6,000 feet. The type of airplane is a Cessna 182. So this is the place where once you learn how to read these, until you understand all the different types of airplanes, this is where you're going to get crossed up, because I'll look at airplane, I don't know what that is. I don't know what kind of airplane that is, right? But I know that's the airplane. And then the sky conditions here is 8,000 overcast. And then the weather, this is the flight visibility, is 4 miles in rain. And the temperature is that the temperature? Yeah, temperature is 5. And visibility, or excuse me, winds 270 at 30. Turbulence is light, and remarks is heavy rain. So that's a pilot weather report. There's not a lot of these out there, unfortunately. Not a lot of pilots give weather reports. But if they're out there and they're along your route of flight, you should look at them. Because that's unlike the radio balloons, you know, this is an upper air type observation. Unlike the balloons that they send up, that get sent up twice, every 12 hours. If a pilot is up near where you're going to be and they're reporting some condition and it's relatively close to the time frame you're going to be there, That's real good information to have, right? So pilot reports are really important. And you'll hear ATC, you'll hear the tower guys, oftentimes you'll say, you know, pilot report appreciate, or give me the tops or the bottoms, or give me a visibility report, something. They're asking for pilot reports, right? I think one of the reasons pilots don't give pilot reports is because they're intimidated by all of, well, I got to give it in this order, and I got to give all this information. You don't have to give it in any particular order, and you don't have to give all the information. You can simply say, I'm here, and the visibility is this, and that's a pilot report, and that'll be useful for somebody. Or I'm here, I'm flying this kind of airplane, and I'm getting my fillings knocked out of my head. It's so bumpy, right? That's useful for somebody. So even if you don't have all of the information, it doesn't matter, and you don't have to give it in any particular order. Just give what you have, and that will get disseminated back into the system and used by somebody else. Okay. All right. TAFs. This is a type of forecast. A TAF is essentially, think of a TAF like a METAR, like a forecasted METAR. All right. TAF is a forecasted METAR. It's valid for either 24 or 30-hour time periods, and then they're updated every 6 hours. Okay, so you'll have, and we'll read these as well, but basically you'll have a TAF that says a valid time is for this 24-hour period, and then it'll go into a 6-hour period and say, well, out of this 24-hour period, this 6 hours, this is kind of what we expect. Then this 6 hours, this is what we expect, and so forth. So the first 24 or 30 hours is an overall, this is kind of what we're expecting in this whole period of time. And then we take this 6 hours, and then this 6 hours, and this, and break it down like that. Okay. All right. And they're updated every 6 hours. So what I mean by that is you'll get a 24-hour period, and then 6-hour periods, and then the next 6 hours you'll get another one. You see what I mean? So if you have a TAF that is, 5 hours old, in another hour you're going to get a brand new TAF. Okay, and they're laid out kind of similar to a. If you can read a METAR, you'll be able to read a TAF. They're laid out very similar. The codes are the same, essentially, and so once you can read one, you can read the other. All right. The thing to think about, the thing to understand with TAFs, unlike METARs, is that there's METARs nowadays. Even little podunk airports have weather reporting stations, and so that becomes a METAR. And that gets added into the surface observations of the entire country. Not all airports or what I mean to say is not all weather stations that have METARs also report a TAF. They don't all have forecasting capabilities, all right? So does this airport, when you look up this airport, can you get a TAF for this airport? If you get ForeFlight, will it show you a TAF?
If I remember correctly, when I do it, it comes up Randolph Airport.
Yes, it'll show you a TAF, but it's not from here. What it's doing is it's pulling the closest reporting station that has a TAF. So be careful, right? So be careful when you look at that. All right, when you're looking when you're looking at a ForeFlight or something like that, and you pull up an airport, a lot of times over in the little information area, you can have METAR, TAF, and when you hit that TAF, if you don't look up at the top and recognize, hey, this is from 16 miles away, you may think this is good for this 5-mile radius area, and it's not, or might not be. All right, so just like with everything else, if you're looking at a TAF and it's from an airport that's 10 miles away, I would trust that more than a TAF at an airport that's 20 miles away. So you got to weigh all this into your thought processes with this. Okay. All right. Okay, in-flight weather advisories. So these advisories, we're going to get into airments and segments and that kind of stuff. In-flight weather advisories, these are advisories that are saying, okay, this can affect you while you're flying. So airments and segments are there so that this can have an effect on you in flight, and you need to take note of these, okay? So airments stands for Airman's Meteorological, okay? information. Airmen's meteorological, okay? So when you think of airmets versus sigmets, sigmets stands for significant meteorological events versus airmen's meteorological events. So when it's an airmet, think of it as it pertaining to me, the airman. And what they're saying is, there's three types. There's Zulu, Tango, and Sierra. And what they're saying is, you need to, whether it's Zulu, Tango, or Sierra, you need to think about you as the airman. Are you capable, and in the equipment that you're flying, are you capable of flying in this particular type of condition? Because it affects you as the airman and what you're flying. All right, so we have Airmet Sierra, that is IFR conditions or mountain obscuration. So if you're a student pilot on a cross country or planning a cross country, or you're a private pilot without an instrument rating and you're planning a cross country and you see Airmet Sierras along your route of flight, that's a no-go, right? Boom, fast, easy decision. That's a no-go, right? So that's an easy one. All right, if you're an IFR pilot and you see Airmet Sierra, it's not necessarily a no-go. Now you have to do some further investigation on those conditions. Doesn't necessarily mean you can't go. Maybe you can, maybe you don't want to, just depends. All right, Airmet Tango, that's turbulence. Well, turbulence comes in light, moderate, and severe. Well, light, moderate, and severe for an airplane that weighs 1,300 pounds is different than light, moderate, and severe for an airplane that weighs 10,000 pounds, right? So one really good upper air observation report that can help you when it comes to that would be a pilot report. So if you see pilot reports along your route for turbulence, and they say, you know, light turbulence, and it's a 737 passing through 6,000 feet, I don't want anything to do with that. You see what I mean? So that's where understanding the type of aircraft is important when it comes to that pilot report. Anyway, so turbulence is light, moderate, and severe, and that's heavily dependent on the aircraft that you're flying. So keep that in mind. And then Airmet Zulu is icing conditions. Okay? Icing conditions we talked about last week. Just because there's Airmet Zulus out there, you need to look at those. Typically they'll give you freezing levels. So they're going to tell you this is where the freezing level's at, and basically what they're saying there is this is the altitude where what happens? Freezing. Where freezing happens, right? And so if you're below that altitude, even if you're above that altitude, what conditions have to exist for you to pick up icing, structural icing?
Freezing temp and moisture. Visible precipitation.
Or visible moisture. You have to fly in visible moisture. If it's clear, if it's dead clear out and it's 0 degrees, you're not going to pick up any ice. Okay? All right. All right, so those are airmets. They include moderate icing, moderate turbulence, sustained surface winds, 30 knots or greater, widespread areas of ceilings. This is for the IFR. Widespread areas of ceilings less than 1,000 feet and visibility is less than 3 miles, and extensive mountain obscuration. Okay, so those are airmets. The way to remember those, the way I remembered them when I started this, was Airmet Tango was easy for me for some reason because it just went to turbulence. Airmet Sierra is I can't see anything. Airmet Sierra, so that's IFR. And Zulu, I just think cold. So that's the way I remember. Your mileage may vary on that. All right, SIGMETs, in-flight weather advisories. Again, these are SIGMETs. So these are advisories concerning non-convective weather that's potentially hazardous to all aircraft. So where airmets, remember airmets are airmen's meteorological. So we think of me as the airman and what I'm flying and what I'm capable of doing. Sierra, Tango, or Zulu, am I capable and is the airplane capable? When it comes to SIGMETs, this applies to everything flying, not just the airmen, everything. So SIGMETs you need to pay close attention to, all right? They're unscheduled forecasts. They're valid for 4 hours. unless it relates to hurricanes, then it's valid for 6 hours. And this is what they're forecasting. Severe icing not associated with thunderstorms. So that means we're not associating the clear icing that can come out of the thunderstorms as a result of the super cool water droplets we talked about last week. Severe or extreme turbulence or clear air turbulence not associated with thunderstorms. So remember clear air turbulence? What that was? It was that tropopause, the turbulent area between the two layers of the atmosphere that caused that clear air turbulence. Dust storms or sandstorms that lower the surface visibility to below 3 miles. Okay, so SIGMETs can give you IFR conditions as a result of visibilities from volcanic ash and dust or sandstorms. So those are SIGMETs, not to be confused with convective SIGMETs. All right, so these are severe icing, severe extreme turbulence or clear air turbulence, not associated with thunderstorms. Convective SIGMETs, on the other hand, are associated with thunderstorms. There we go, convective SIGMETs. All right, severe thunderstorms. And we get a lot of convective SIGMETs around here, in the summertime especially, okay? So, severe thunderstorms, surface winds greater than or equal to 50 knots. That's pretty extreme. Hail at the surface greater than 3/4 of an inch in diameter. Tornadoes, okay? Embedded thunderstorms, lines of thunderstorms. Thunderstorms producing heavy precipitation affecting 40% or more of a gigantic area, 3,000 square miles. So those are convective SIGMETs. When we get to the internet portion of this, probably we'll get to it in the next hour. I'll show you. It's kind of nice because you can turn these SIGMETs. You can turn on the airmets and the SIGMETs and the convective SIGMETs graphically. Used to be when you got these reports, if you got a chart, they'd have them kind of laid out. But if you just got them textually, they would give you latitude and longitude, or they'd give you bearings and distances off of VORs, and you'd have to get a map out and you'd have to draw your own line of where these things existed before you flew. Now you can just push a button and it gives you it graphically shows you where it's all at. All right. Next thing we want to get is winds and temperatures aloft. This is a forecast. Made twice a day based on the balloons that we send up. And by the way, we don't send balloons up all over the place. Like not everywhere sends up balloons. They're sent up in different places around the United States, and then they interpolate that data and figure out what the winds are going to be at different altitudes in different places, and they forecast that stuff. Okay. There's a couple different places where you can get the raw data for this. I'll show you that when we go to the website area. But the 800WX Brief site has added a tab, which I'll show you, which is really neat, where you can go straight to it right from the map now, which is kind of cool. All right, and you need this information. Why? Why do you think you need this information? Why do you think you need to know what the winds are at altitude? What purpose would that serve?
It'll certainly help with planning
Yeah. Well, yeah. You don't know how fast you're going to be going. You don't know what your ground speed is going to be, right? So you have to know. You got to know what the winds are up there to calculate your ground speeds and all that kind of stuff, and your fuel consumption. All right. Some of the charts that we're going to look at. This is an older one, but this is a surface analysis chart. I'll show it on the internet-based site. We'll show you an actual one, but this is a surface analysis chart. And it basically just shows you the weather, the frontal system, the highs, the lows, the troughs and things like that we talked about last week. Storms along the fronts and that kind of stuff. We'll show you that. The surface analysis chart and weather depiction chart, and I'll kind of scroll back and forth between these. These are the two same charts at the same time, so you can see that the highs, lows, and frontal positions are in the same place, but they show some slightly different things. Okay, frontal boundaries and everything is the same, but with the weather depiction chart, it shows IFR and marginal IFR and VFR stuff. So IFR, marginal, VFR, everything else would be VFR. It kind of shows areas like that. But with the graphical representation now that you can get on 800WX Brief, it's just way better than it's way better than this. These little symbols you see here, these are the weather stations. So here at New Braunfels, if we could zoom in, there'd be one for New Braunfels. And it's basically, this is showing you that for here it's clear skies. You know, here it's overcast. Here it's few clouds. Here it's broken. You know, it's just showing you the cloud cover, the sky conditions. It's not showing you what the altitude is or the ceilings are, but it's showing you the cloud cover itself. Okay, I want to move to, any questions on that stuff that we talked about right there?
Just about PIREPs.
Okay.
So for PIREPs, are they given directly to ATC only, or approach, or whatever frequency?
Any ATC facility, you can give them to any. You can give them to flight service, or you can give them to ATC. They eventually all get back to flight service, who then disseminates it out through the National Weather Service, and they get on the charts and the maps and all the reports. But you can give it to ATC, or if you're talking, it's more likely you're going to be talking to ATC, so give it to ATC, and then they pass it back through the system. But you could also, in flight, you can talk to flight service in flight, right, and get weather briefings. I'll show you when we get into the maps. I'll show you how to do that. You could talk to flight service in flight. You could give them pilot reports as well. Doesn't matter who you give it to. Okay, I'm going to go ahead and move over into here. First, let me go home. All right, so that's the home page. Everybody has an account here? All right. So the first thing I'm going to say is how many of you kind of looked through it? How many of you have gone through it and kind of just looked around? How many of you have gone over and looked at it? Well, let me log in real quick. And now let me go to here. How many of you have gone through and maybe looked at videos or how-to videos or any of that kind of stuff on the site? All right, so there is a lot of fantastic videos. There's a lot of good information, a lot of stuff you can learn by going through some of these videos on this site. How-to videos, as well as seminars, weather, just all kinds of good stuff. The other thing I'll tell you about this site is that they update it a lot. They're constantly updating it. So between the last time I taught this class, so that'd be 14 weeks ago, and now, I just noticed that they added the winds aloft thing I was talking about. I used to have to go through and back into winds aloft raw data. Now you can get it right off of the interactive map, which is kind of cool. So there's other places you can get your weather information, right? The FAA says we are responsible to check the weather, the current forecast conditions at our departure, along our route of flight, and at our destination. They don't say how, they just say we have to do it. So there's a number of ways you can do it, but however you do it, you have to be able to prove that you did it, or else, because 91-103 is a regulation. It means that's law. That's a federal law. So you have to abide by that law. Well, if you have to abide by that law, that means that there needs to be some means in place where you can prove that you did. So where would this come up? Well, let's say you fly someplace, you have an incident or an accident, you don't get hurt, but if something happens, the FAA gets involved. They're going to want to know that you checked weather. Well, how do you prove that you checked weather? So that leads to the question of what's a legal weather briefing? What does that mean to get a weather briefing? Okay. Well, you just have to be able to prove it. So there's a couple of ways. If you called 1-800, or if you called 800WX Brief, if you called them on the phone, then there's going to be a record of that call. There's going to be a record that you called and got a briefing. If you log into this site, there's going to be a record that you were on this site. Even if you don't say, give me, which I'll show you in a minute here, even if you don't click the button that says, give me a briefing, every keystroke is logged. every page, every map, every chart, everything you looked at, there's a record of. So you have proof that you self-briefed, even if you didn't hit a button. Nowhere in the FARs does it say you got to hit the button that says give me a briefing. Nowhere. Nowhere does it say you have to call 1-800-WX brief. Nowhere. It says that you're responsible for checking the weather, the current and the forecast weather at your departure, along your route, and at your destination. So the key here is you have to be able to prove, you need to do it, and you need to be able to prove it. Okay. So you can use this site. You can get into the site and you can take advantage of everything in this site without having a login, user ID and password. Everything is available to you, but now none of it is provable. So that's why you want to log in. Every time you go here, you log in under your name so there's proof, all right? So that's a legal weather briefing. The other thing is there's many places you can get all this. You can go to the National Weather Service, and when you, if you don't have these, I'll have Sebastian print them out. There's all kinds of places where you can go and get this information, okay? And it's all good, great information. One problem that's happening now with weather is that there's so many places you can get it, it gets kind of confusing. You can get it from ForeFlight. And that's perfectly legal because when you're logged into ForeFlight, you're logged into ForeFlight. So that makes it absolutely legal. And all of the weather that you get there is great. You get all the same kind of stuff. You can get a briefing right off of ForeFlight. You can file a flight plan right through ForeFlight. You can do all of that in ForeFlight. So the point of what I'm saying is it doesn't matter really where you get it. It's just that you get it and that you understand what it is you need to get. So what is it that you have to check? That vague 91103 about weather, what is it that you have to get? 3 things. Well, 2 things in 3 places. What is it? Current and forecast in what 3 places? Departure, destination, and along the route. That takes the vagueness out of that. That's what you have. That's what it says. When you're responsible to get the weather, check the weather, what it's saying is you're responsible to check 2 things, the current and the forecast weather in 3 places, where you're leaving, along your route, and where you're landing. Okay. What site you go to get that, what meteorologist you talk to, whether you talk to a meteorologist, whether you self-brief, whether you hit a button that says brief me, doesn't matter as long as you can prove that you did it. Okay? That's the whole key to the legal weather briefing. Okay. So look around the site and look at all these videos in here. They're great. Down here in these resources, there's a lot of great stuff in the resources. All these how-to videos, student pilot journey poster. I mean, there's just fantastic information in here. Okay. I'm using this site in this class because I'm using this site. I could just as easily get up here and use ForeFlight, but I'm using this site. Not everybody has ForeFlight. Everyone with an internet connection has access to this. Okay. All right, so across the top here, you see home. This is the home page that I'm on. And then you can have your dashboard. And on your dashboard, you can set up different charts over here. You can have different charts set up. Whatever chart you want to, whatever chart you want to use most of the time. Right over here is the interactive map, which this is where we're going to spend most of the time in this interactive map right here. Down below here, you can set up 3 airports to pop up all the time. I have 3 airports here. I have our airport here, KBAS. I have my home airport back in Chicago, and I have my airport in Lakeland where my mom lives that I fly to occasionally. So these are 3 airports that I typically have set up here. All right, and it shows the METAR, or you can click it for the TAF, or you can show the NOTAMs. It'll show you airport runway closures and stuff like that, however you want to have it. Here's that button I was telling you, it says plain text. All right, so if you look here, if you look at the METAR, let me zoom in on this. If we look at the METAR here for KBAS, so this is a specie. That means that something changed, something happened with the weather that caused a new report to come out outside of the normal 1 hour reporting period. So typically you'll see weather reported at about 50 or 52 minutes past the hour. In this case, it was reported at 13 minutes past the hour, 14:13. So something happened with the weather that caused an update, all right? But the weather right now here is, it's at the 27th. It's the 27th of the day of the month. 14:13 Zulu was when this report came out. So this report's how old? What's that? 36 minutes old. Okay, so the validity of it is, you know, whatever. Okay. Winds are 180 at 15 knots, gusting at 26. Pretty windy. Good visibility, 10 miles. The sky conditions are scattered at 1600. The temperature is 27, dew points 22, altimeter is 3002. Remarks is that this is an automated report with precipitation discriminator. This is a remark here that the peak wind, so this gust 22 or gust 26, peak wind came at this time, whatever. See, here's where I would go. I would do that, and we'll read what this is. This is a detail on the temperature dew point. So 27.2 and 22.2 on that. Let's.
Is that peak wind 19026? Yeah, then the time 14.
At 1408, yeah, that's what it is. All right, let's go back and do this now, and you'll see how you can learn to read these a little bit better. Click this, and now it opens up and gives you plain text. So it's a special New Braunfels, but you can see how much lengthier it gets. So if you have a whole string of those, man, it takes a long time to read all that information, but once you get used to reading the more coded format, you can just go through it much quicker, especially if you're trying to isolate and look at particular things in there. It's just much easier to find, much easier to read, okay? All right, same thing with the TAFs. Now, let me go back to coded format, turn on TAFs. The only airport that has a TAF here is Lakeland. Both New Braunfels here in Aurora and Chicago don't have a TAF, but Lakeland has a TAF, so let's look at this. I'll show you how this reads. So here's the 24-hour period right here, okay? And so overall for the 24-hour period, so this came out on the 27th at 11:30 Zulu, and it's valid from the 27th at 1200 Zulu to the 28th at 1200 Zulu. So there's your 24-hour period right there, okay? And overall, what they're saying is that the winds are going to be variable at 3 knots with greater, the P is plus, 6 statute miles, okay? Few clouds at 4,000, broken at 25,000. So that's the overall 24-hour outlook, if you will, for that time period, all right? But then it breaks down these 4 6-hour periods, and it says, okay, but from the 27th at 1900 Zulu, okay, so starting at 1900 Zulu within this time frame right here. Beginning at 1900 Zulu, winds 2606 knots, plus 6 statute miles. Thunderstorms in the vicinity. I don't know why they do that backwards, but vicinity thunderstorms. Scattered 4,000, cumulonimbus clouds, broken at 25,000. So there's a little change. In this 6-hour period, there's a change from the overall 24-hour period. And then in the next 6-hour period, they're forecasting a marginal VFR. All right, so temporarily, they're saying temporarily on the 27th at 20 Zulu, from the 27th to 24 Zulu, for a 4-hour period here, winds variable at 15, gusting at 25. All right, let me just give you a warning right now. If you see variable at 15, gusting at 25, be really concerned. If you see variable at 3, that's pretty common. When you see variable at 15, that's not good, okay? Variable at 15, gusting at 25, 3 statute miles, thunderstorms and rain, broken 4,000 cumulonimbus. So the reason it went to marginal VFR is that the visibilities went to 3 statute miles. So it's still VFR, but it's not greater than 5 miles, right? Marginal VFR is 3 to 5 miles. and 1,000 to 3,000. So if you get within that window, you're going to go from a green color to a blue color. All right, and then the next 4-hour period, from the 28th at 00 Zulu, the wind 070 at 5 knots plus 6 miles, thunderstorms in the vicinity, scattered 4,000, cumulonimbus broken 25,000. And then the last period from the 28th at 0200, variable at 3 knots. So back to something that's more typical. Typically when you see variable winds, you're going to see the speed at like 3 to 5, something. When the winds are very small, it's very typical that they do this. The stronger they are, the more they tend to stay in a direction. So when they're strong and they're variable, you have bad stuff happening in the atmosphere, and that's not something you want to be flying in a small airplane. So you see this, stay on the ground. Okay. All right. Variable 3 knots. Yeah. Did we go through all that? Variable 3 knots plus 6. Few at 5,000. Broken 25,000. I don't remember what that means. Let's see what that means. See, some of these they don't come up that often, and so I'll. Feet? I don't know. I don't know what it meant. Nothing there. You know what it means? Are you familiar with what the equal signs mean here? No, I don't remember either. Yeah, I'd have to check the code for it, but anyway, you get the picture there. All right. So with a TAF, you've got your 24-hour period, and then they break down the 4-hour periods, or they break down 6-hour periods beyond that, or whatnot. Okay, so this is the dashboard. So on your dashboard, you set this up however you want to set it up. You can customize this to show what airports you want to show, what charts. I think you can put 5 charts in here, and you get the weather. You get the weather charts from the chart section right up here, weather charts. If you click that, here's all your weather charts that you can get. So you could pull any of those into that dashboard that you want. We'll go through that in a minute. Okay, so here's an example of the current surface analysis chart that I was showing you before. So from the standpoint of a go, no-go decision, let's kind of just start talking through that a little bit. Usually the first thing I look at is this chart right here. That's usually the first thing I look at, because it's the biggest, the widest, expansive picture of everything that I can see. And then I'll go from that, and then I'll start drilling down from there. Okay? So we're right in here somewhere. So from a big weather standpoint, if it's just a local little flight, there's nothing that's really scaring me too much in this picture. If I'm flying up in here somewhere, I'm a little more concerned. Now I've got to drill in a little bit deeper, right? All right, but what this is showing us is our fronts. There's our cold front, there's stationary front all the way through here. So stationary front, what do we say that means? Between these two weather systems, between these two air masses? Last week, what did we say is happening here? It's not a cold front, it's not a warm front, it's a stationary front. Neither one's overtaking the other. So you're going to get all this instability and bad weather along this line right here, and it tends to stay there for a long time because neither one is really winning, and it just kind of until you have something other, maybe another system that moves through, or a jet stream steering streams that move it out of the way. But the air mass itself isn't they're not really moving anywhere too far. So you get a stationary front that can sit on top of you and just kind of crap on you for a few days sometimes. So that can happen along stationary front. All right, and then you see the what do we call this? What was that? Trough? That's a trough, right? So a trough, think about a trough, kind of sort of like a stationary front, in that you've got this area of low pressure, an elongated area of low pressure, where all that bad weather, it's like a French drain, all that bad weather just drains right down into that. So you could get bad weather along that. What do we need there? What would we need a sufficient amount of right here to get some bad aviation weather. A sufficient amount of what? Who said that? Moisture. Yes. You'd have to have a sufficient amount of moisture. Okay. That's a surface analysis chart. This is the weather depiction chart. So again, it's the same. I don't typically look at this anymore. I'll show you why in a minute, because when we go to the interactive map, everything I can get off of here, I get on the interactive map. Again, it's the same frontal systems, and it gives you some reporting stations with sky cover, but there's just no good information on here for me anymore because of that I use because of the interactive map. So I really ought to take it off of my dashboard. All right, let's move to, well, actually, I tell you what, it's 10 o'clock. Let's take a quick break, and then when we come back, we'll get into the interactive map here. I'll show you all the stuff on the interactive map. This, again, I remember I told you this came out of the back of this AC, so I would encourage everybody to download that AC and read through that AC. But this is just out of the back of this AC right here, okay? But what the AC it was set up for is because the FAA really because of the technology that's out now, the FAA really is encouraging. Put this on. The FAA is really encouraging pilots to self-brief and learn how to self-brief. And that's what that AC is about. So this is kind of a checklist on what to look for the different briefings. So your Outlook briefing, your standard briefing, or your abbreviated briefing. And the last page of it is really the checklist. If you're doing an Outlook, a standard, or an abbreviated briefing, these are the things that you want to make sure you get. Make sure you're looking at these things, right? So adverse conditions, synopsis, current weather, all that kind of stuff. This is at all three locations: departure, along the route, and destination airport, okay? So use this in your preparation when you get weather. If you open this site up and you're like, well, my gosh, what do I look at? Well, use this. These are the things you want to go looking for when you're here on the site, okay? All right. Let's look at the chart here, the interactive map, and show you about this. So I've turned all of the layers off. So it essentially, and I have it set to a VFR overlay, okay? So first of all, you can have the map, you can have the chart set to whatever overlay you want. Once you become IFR rated, you can have it show you an IFR chart. There's an IFR chart. But for our purposes, we're going to have a VFR chart. So I'm going to go ahead and zoom in here a little bit to kind of where we are. So when you zoom in here, well, that's not where we are. We're down here. So there's us right there. There's New Braunfels. So you can see it's just a sectional chart. We've got the sectional chart overlay. And this will always be the most current sectional. It's always going to be the most current chart. I'll turn on some overlays and I'll show you what's available here. Let me just kind of back out, get the whole US. Up here's the overlay, and there's multiple things that you can turn on here. And I'm gonna just kind of do them one at a time. So first off, we'll look at METARs and TAFs. So if I click this, I'm gonna get all the METARs and TAFs. So these are the reporting stations, the little circles that were on the other chart, right? That were either completely open or closed in some fashion. So that one's open, that one's partially closed, right? So this is giving you the sky condition as far as the ceilings, if there's a ceiling, or if it's sky clear, few, scattered, broken, or overcast, and it depends on how open the circle is, essentially. And it gives you the color, whether you've got VFR conditions, marginal VFR conditions, IFR conditions, or low IFR conditions, all right? So we can zoom in. The farther you zoom in, the more stations become apparent. The farther out you are, these are going to be big airports, big reporting stations. You know, Chicago O'Hare as an example, right? As you zoom in, you're going to get the more detail, and smaller airports will pop up. So the closer you get in, you get down here by us, the more you zoom in, the more reporting stations will pop up for you, all right? So we'll just go down here to where we're at. So here you see New Braunfels, and when you click on it, you'll get the METAR. Who else needed one of these? Who did not get one? There you go. Anybody else? There you go. Okay, so so from the standpoint of just, you know, checking, let's say, you know, your airports or flights along the route or departure or destination, you know, you could go right here and get that information. This information comes right up in ForeFlight as well, right? Everybody familiar with seeing this in ForeFlight? You're getting the same kind of stuff out of ForeFlight, okay? All right, so we can go in and read, here's San Marcos right here. Let's go in and read a few of these, see if we can learn how to do this. I'll let you guys do it. Let's just pick one out here. Let's go over here, wherever this is. Stevens County. All right, so is that readable? You guys see that? Kevin, you can see it. You're right up front, so you get to be the guinea pig. What's this saying here? One of you guys up front that can see that? So we got the airport identifier, day, time. So that's 20 minutes old. So this is the wind. This is the wind information right here, 190 at 17, gusting to 23. Visibility, clear skies, temperature dew point, altimeter, remarks, and then this is a more detailed description of the temperature dew point. So 29.9 is the temperature, not actually 30, and 20.5 is the dew point, not 21. Just getting it, fine tuning it a little bit, right? Into the report, yeah. That's Kevin did the same thing. Into the report. In some cases, it means fog, but if it meant fog, it would be over here, and it would be near the visibility area. Yeah. Okay. Let's see if we can find one with. Let's go to one that's going to have a TAF. So there you go. So here we got a TAF. We got a METAR and a TAF for Dallas-Fort Worth. So for Dallas, we've got Dallas-Fort Worth, 27th at 1453 Zulu. Winds are 200 at 21, gusting to 29. Pretty strong winds. 10 statute miles. Okay, now we have the ceilings, if there is. So this is all sky condition here. So broken at 25,000, so real high clouds. So no problem there. Temperature 29, dew point 22. What does that tell you? What practically, what's it telling you? Temperature's 29, dew point's 22. We got a 7-degree spread. Huh? Means what? Go ahead. Go ahead. What are you gonna say? Well, it may be humid, but there's a big enough spread where the visibility's good, and the ceilings, the clouds are way up there. Visibility's good, and the clouds are high because we have such a big spread. We have a large spread between the dew point and where it would become saturated. All right, so from a practical standpoint, that's what that means. Altimeter is 2995. What does that mean? Forget temperature for a second, just from a pressure standpoint, what does 2995 indicate to you? Pretty close to standard, a little higher than standard actually. Yeah, a little higher than standard. Let me stand out of the way so everybody can see this. Okay, let's see. So remarks, AO2 just means that it has a precipitation discriminator. All right, here we go. Peak winds, we're 200 at 30 at 1441. Sea level pressure is, that's millibars, 1300. And then, again, this is just a detail on the temperature dew point. And then that, I am not sure of. That's the end of report. I don't know what I'm not sure what the dollar sign means. But to be quite honest with you, I don't really care. I really don't. You can look it up if you want to. All right, the TAF. This is an amended TAF, so something changed. So it's kind of like SPECI with the METAR. This was an amended for some reason. So for DFW, 27th at 1457 Zulu, and this covers a period of time from the 27th at 15 Zulu to the 28th at 18 Zulu. So that's the period of time this covers. Winds expected to be 180 at 20 knots, gusting to 28. Better than 6 statute miles, scattered at 25,000 feet. That's the TAF for that particular report. Okay, so if we look this up again, if you look this up in plain language, you can get it in plain language, but it takes a long time to read. This is just really quick and easy to read once you get the shorthand, and there's not that much shorthand that is of substantive value, right? These little esoteric dollar signs and equals, when you find them in here, okay, so the METAR is laid out where you're going to have the identifier, the date and time, the wind grouping, the visibility grouping, the sky condition grouping. When you get these odd symbols in the visibility grouping, then it's giving you an indication of what's causing the visibility to be low, right? So if you see something like 2 statute miles or 3 statute miles, something with low visibility, and you have this other thing near it, that other thing near it's telling you why it's low. Mist, fog, something along those lines, giving you the reason for the low visibility. Smoke, whatever, right? Okay? All right. Okay, let's look at one that's bad. Here we go. Here's one here. Here's an IFR. Up here at St. Louis, Lambert. All right. Why are we IFR here? If you can see that.
Overcast 1,300 feet.
No, that wouldn't make it IFR. What makes that red? What in here makes that red?
Broken at 900 feet.
900 feet. That's what makes it red. So ceilings below 1,000 or visibility is less than 3 miles. What are the visibility here? So it's not that. So it's the ceiling, right? So you got it broken at 900, overcast at 13. So you've got 2 ceilings, but what makes it IFR is the lowest of them, right? Okay.
And visibility is always measured after alpha.
The visibility, well, this is all, yeah, this is the airport stuff. So this is visibility right here at the surface in this case. You could also get runway visibility, RVR. Sometimes you'll see these with RVRs, and that's giving you the runway visibility. So that's telling you how far down the runway are you gonna be able to see.
So presumably you could have a ceiling at 500 feet and still 10 miles.
Correct. Yeah, absolutely. All right. So look at the what's the temperature dew point here?
26, 23.
So we got a 3-degree spread. So that's giving you an indication of what's causing those ceilings to be so low. Remember, the closer together the temperature dew point is, you're going to get one or both, one or the other of this thing or both of these things happening. Low visibilities or low clouds. Because we're reaching saturation in the atmosphere. The closer the temperature dew point is at the surface, the lower the visibility and the lower these clouds are going to get. So we want to see, as VFR pilots, those big spreads. When you see narrow spreads or spreads narrow, can't say that, getting closer, then you know that this is this type of stuff that could start happening. Okay. All right. So that's the airport METARs and TAFs that you can turn on and off. So I'm going to turn that off because everybody knows what that means. Weather cameras I'm not going to get into, but they have different weather cameras around that you could go and look at cameras, at this airport, see what's happening right now. I never really used that because I never am going to an airport that has a camera. So I don't care that much. All right, pilot reports. Here's different pilot reports. around the area. Let's come look at some pilot reports down here near us. There's one here. All right, so that's a routine report. There are 4 nautical miles. They're 4 north of Austin at 1448. The flight level 2,000. So they're 2,000 feet, basically, so it's low. Well, and it's a CRJ, so it's a jet, and broken at 3,000. So they're just telling them what the cloud cover was, what the basis of the clouds were. All right. So that information then will go into this ATIS report for Austin right here. All right. So there's an example of pilot reports. TFRs, you could turn on TFRs. There's all the TFRs around the country right now. Again, all of this stuff, or most all this stuff, you can get on 4Flight. Okay. Segments. All right, let's turn on the segments, and now it's going to open up convective segments, and convective outlets. So let's look at them one at a time. So there's convective segments right there that are graphically shown. All right, and it's basically giving you the information as to where they are, and so this is the kind of stuff that I used to have to do. I used to have to get this 40 north-northeast of SGV, 40 west-southwest, and get a map out and draw that myself if I wanted to know where that was. So this is so much nicer. You can just click the button and it gives it to you, not only in textual format but in graphical format. So those are convective segments. So those are areas that you probably don't want to be flying in, especially in a light airplane. Okay, these are segments, and then these are convective outlooks. So these are areas where convective activity, the potential exists. Watch out in these areas for convective activity or convective segments to pop up today. All right, so we look pretty good down here where we're at today. I think it's going to be a little windy today, but we're relatively okay from a segment and convectivity standpoint. So let's turn that off. Let's look at air mets. Here's your air mets right there. All right, we'll look at them one at a time. So there's Tango. Those are turbulence, air mets for turbulence. And so that's high, so that's moderate, 34,000 to 42,000. We don't have to worry about that. All right. In that case, if it says moderate and you're at that altitude, you're probably flying something that you kind of know what that means, as far as aircraft that you're flying. Let's turn that off. Air Met Sierra. So these are areas of IFR conditions, or mountain obscuration. These are the mountain obscuration right here. And these are ceilings below 1,000 feet or visibilities below 3 miles. So these are IFR, and these are mountain obscuration in that color there. But all of them are Sierra, Air Met Sierras. Air Met Zulu, area freezing. So you've got freezing over here. You click it, and the base is at 13,000 feet, top's at 24,000 feet. Okay, so that's basically where you're going to have freezing levels. So if you're in those areas, in this area right here, and you're flying in visible moisture, the potential to pick up ice is there. Okay, and then we can have you show the freezing levels. Here's your freezing levels. So if I come over here, the freezing level is 16,000 feet. So if I'm below 16,000 feet, probably not too concerned about picking up ice. I want to stay below 16,000 feet. Obviously, those freezing levels are going to change depending on the time of year. So in the wintertime, those freezing levels get a lot lower. Okay, makes sense? All right, center weather advisories. So you have to click on that to see what it is. Just from the Weather Service Center, weather advisories there. Severe weather. Severe weather warnings, nothing out there. Winds aloft. All right, so here's where, this is what was new to me from the last time that I looked at it. I'm not sure how long it's been on there. When we come down here to San Antonio, you got winds aloft right there. And you got raw data for winds aloft right there at San Antonio. So it's giving it to you from, and this is the forecast time, from 1400 to 2100 Zulu, or from 2100 to 0600 Zulu at 3000, 6000, 9000, and so forth. So at 6,000 feet, 180 at 24, 20 degrees Celsius. Right down the line. So you get winds aloft, so when you're doing your cross-country planning, you go right here, rather than having to go back in different places to get the detailed winds aloft, or you can get it from ForeFlight. ForeFlight gives it to you as well. Again, you can get this information in a lot of different places. Important thing is know what information you got to get, and this is where you would get it from this site. So winds aloft, you could get right there. If you're flying across country that takes you from, let's say, the San Antonio area up in this direction, maybe as you go through here, you want to check winds aloft here. Right? So this information may be a little different than San Antonio. So as you fly, you're going to get the winds aloft from the closest station to you, to your route of flight, and use that information for planning purposes. There's your winds aloft. Graphical winds aloft. Okay, so here, you get in this, it'll give you just these little areas where you can just click on the area and it does the same thing. So for that area, now it's going to be interpolating between these zones, if you will. So now rather than going from here to here, I'm in this zone, what is it in this zone and in this zone? And it's kind of doing that interpolation of the wind for you between the areas. So this is really kind of cool when you're going to do your cross-country flight planning. Okay. All right. Radar. Got a lot of different types of, let me turn off the winds aloft here. Got a lot of different types of radar that you can pull up. Really, the only weather radar that's showing up is kind of up in this area, so we'll just zoom in this area. So you can get base reflectivity, and I'm not an expert on the different, all this kind of stuff, so you might want to do your own research a little bit on what some of this stuff means. I can tell you echo tops mean a lot to me. Okay, this means a lot to me because I come down to this scale down here, and this is telling me how many thousands of feet up in the atmosphere the tops of these storms are. So these guys over here are going up like 45 to 50,000 feet. So based on our conversations last week, what does that mean? You got a storm, you got storms with such extensive vertical development that they go up to 45, 50,000 feet. So these are probably popping up into the stratosphere. They're popping up through the troposphere, through the tropopause, right? So these are going to have those anvils where you reach the tropopause. These are strong enough where they're probably busting up through that. So what kind of weather are you going to get out of these? Like really, really bad weather. The taller the cloud, the higher the tops, the worse the weather. The potential for the weather. You're going to get tornado or potentially tornadoes, giant big hail coming out of this stuff. I'm sure there's convective segments around this. Let's see. If there's not, I would be very surprised. Oh yeah, right there. Right on top. Obviously, because of all, there has to be, with that stuff going on, there's got to be convective segments right there, right? Okay, so turn those off. So tops, there's not going to be any winter storm. Composite. So the difference between the composite radar and this, I think what's happening with the composite radar is it's taking different radar. If I remember correctly, it's taking different radar facilities that will only give you, like if you look at just the radar itself, you see like a little circle. And you look at this radar, you see a little circle, and it's just kind of interpolating and stitching those together, giving you a composite view of what it would look like if you could get a radar for the entire thing, as opposed to a satellite view, right? Radar view, okay? and then you can get satellite, which isn't giving you, it's giving you basically the cloud cover, but it's not showing you the stuff inside it. Okay. And then you can also get unmanned UAV, unmanned operations, UAS operations. Get that information on where those are located. All right, so you can get you just get a lot of information right here off of this interactive chart. Okay, the other thing you can do right here from this chart is you can get a flight plan right out of the chart right here. Actually, let me come back to that in just a second. Let me go back to the weather charts real fast. So these are the different charts that are available through this site. The surface analysis of the weather depiction. I showed you freezing levels. This is we were able to get this off of the interactive map as well. But there's your freezing levels right there. And it shows you this is the 16,000 foot freezing level right there. This one's at 12,000 feet up here. A lot of the stuff you get right out of the other interactive map. Surface prog charts. This is one to use. This is something to use, especially if your flight is 48 hours in advance. Remember the Outlook briefing? Outlook briefing will use this chart. So it's 12, 24, 36, and 48 hours. So this shows you what the forecasted weather should be 12 hours from now. Then you click over here and it'll go to 24 hours, and that's where it's moving in 24 hours. Then you click it again. That's what it's supposed to look like in 36 hours. And this is, remember I talked last week? Remember I said these were troughs? And then you have this other thing that looks like this. What did I say that was? That's a dry line. That's the dry line I was talking about. So you get a lot of weather along the dry line. That's your and then that's your 36-hour outlook or prognosis, and then that's your 48-hour prognosis. So this is what the weather is expected to do between the next 12, 24, 36, and 48 hours. And then you can set that, you can make it run fast, and you can just put it in motion and let it run through. So you can kind of watch it move over the time. So if you have a flight that's in the future within the next 2 days, this is a big picture look of major systems movement. And again, this might be able to give you a go decision 48 hours out in advance, but more than likely what it's more likely to do is give you a no-go decision. Okay? Actually, more than likely it's going to give you, I just got to keep watching it kind of decision. Okay? But this is a valuable tool, especially in that outlook stage, a valuable thing to be looking at. All right. Let's see what else I want to look at on here. Winds aloft. I'll show you real quick. Before we used to have to go over here to winds and temperatures right there, and this would take us to a different site. Okay, you could go to this different site, then you could go to product, and there's your winds. You go to products, and you could go to, let's see, where was it? Winds and temperature data right here. And then you'd have to go to South Central right here, and there you go. There's your winds and temperature. And you come down to San Antonio, and that would be your winds and temperature right there for San Antonio. So it was a much longer process to get to than having it on the chart. All right. All right, let's go back to here and go back to the map, and I will show you some cool things here. When this is up, when the flight plan form is up, and you can also set this up with different aircraft. If you fly different aircraft, you can set it up. So I have it set up for a GX, so it has the profile in there for the speeds and the performance stuff for the GX. But if you fly different aircraft, you can have different aircraft profiles set up. So when you go to do a flight plan or you go to do a briefing, it takes all that information automatically and kind of plugs it into the plan for you. So it's one less bit of information you got to put in. So we'll just do a quick KBAS. I don't know, let's see. Let's do just something. Let's go to VCT Victoria. Okay, VCT right there. And it'll put that on the line for you. And it'll give you this, you can kind of see the outline going around it there. That's the corridor that if you get a briefing, the way it's set up right now, the briefing is going to include all the weather it can find within that corridor. So that'll be your route, so to speak. So everything it can find, METARs, TAFs, anything within that corridor, that's what it's going to bring back to you, okay? All right. So you can from right here, you can go straight to plan and brief. So let's just do that. I'll show you real quick. Right there, and it's going to bring up another page here, and this would be the flight plan briefing page, where you put in your aircraft, your flight rules, and all the information you need to put in here for the flight, and then you could come down and get a route briefing right here. You get your route briefing off of that. So let's just go through. I'll show you the stuff here. It's pretty straightforward. You put your aircraft ID here, flight rules right here, and if you're not sure, obviously that's pretty self-explanatory because it'd be VFR. But if you weren't sure, you click on, well, let me go to this one, flight type. Well, I don't know. What flight type am I supposed to use here? I don't know. Well, click up here, and then it tells you, it gives you detail on what it is you're looking for there. First of all, flight type is optional, so you could leave it blank. But if you didn't leave it blank, you'd put G for general aviation, right? So you could put G there. Number of aircraft, well, there's just one. We're by ourselves. Aircraft type is a GX. Wake turbulence. Well, is my wake turbulence level low, medium, or high? So what they're asking here is, what kind of airplane are you flying? So, unfortunately for us, low is any aircraft that weighs less than 15,000 pounds. Well, there's a big difference between an airplane that weighs 1,300 pounds and one that weighs 15,000 pounds. But we're low. We're on the low end of low. So we would be low, okay? All right. Aircraft equipment. So I already have it set up as S, but the equipment that it's looking for here is, this doesn't give us a whole lot of information, but if you come over here to this box, it gives you the information that you're looking for. So this is the type of equipment that you could put in that box, okay? So basically, what do you have in the panel? What do you have in your airplane, okay? So for our planes, I just put in S because it has a VOR, a VHF radio, and an ILS. So I put S in there. That's what we have in the airplane. So S covers it. Or I could go through and I could put each one of those individually in there, and it'd be the same thing. All right. Okay, why is that not? Oh, down here. Okay. All right. The departure is KBAS. Now, right here are a couple of interesting boxes. I can get information about the airport right here by clicking that, and look, I get New Braunfels information right there. So I have it available to me right there. I can also just simply get an area brief right here around New Braunfels. Now, I didn't put enough information in yet, but what I'm getting at is, if you want to come out and fly, if you're just going to do a VFR flight in the local area and you just want an area brief for around New Braunfels, you can do it right there. You don't have to have a flight plan going anywhere. You can simply put New Braunfels in, and you have to give it a little bit more information, like, for instance, your departure date and time. Okay, but you could get a briefing that would just basically take New Braunfels and give you a circle around New Braunfels and give you a briefing for this airport. I'm not going to do that, but that you could do that right there. Okay. So let's put in our departure date and time. So we'll put today's date is 06/27. '26. Okay, and the time required, let's say we're going to leave at, I don't know, let's call it noon local. So I think 1200 is what they want there. It'll scream at us if we have it wrong. All right, let's say the cruising altitude. Well, first of all, we're going kind of southeast, so what's our cruising altitude options? If we're above 3,000 feet AGL, what cruising altitude options do we have? What's that? Even +5 or odd +5? We're going southeast. Odd +5. Okay. So let's pick 5,500. All right. So I'm just going to put 5,500 in there and just see what happens. Okay. Surveillance equipment. This again is another one of those you got to look up and see what kind of surveillance equipment we have. We have a mode C or mode A transponder, and we have ADS-B in and out. So CU2 is what I've got here. So we're good on that. All right, that's the type of equipment we have on board the airplane. Okay, the destination is VCT, and again at VCT, I've got those same two boxes. I could get airport information for VCT right there. Or I could get an area briefing just for VCT right there if I wanted to. Okay. Alternate, I don't need an alternate. I don't need an alternate 1 or alternate 2. Fuel endurance, let's say we have full fuel, so I'll put 4 hours there. Let's say we got 2 people on board. Aircraft color is white. Don't need to put any of this stuff in here. Emergency radio is a emergency locator beacon. Survival equipment, we don't really need any of that. Jackets, nothing of that. We're not worried about any of this. Pilot contact information over here. And there we go. So let's just go ahead and see what happens if I hit route brief. It's going to scream at me because I got some stuff in there wrong. But I did it on purpose to show you. So I'm going to do a route briefing and see what it does. It's going to come back and say, oh, you got some stuff wrong in here. We don't like this. Please correct these fields. Required fields may be incomplete or fields have invalid data. So the departure date, cruising speed, and level are all wrong. So let's come over here, say okay, departure date and time. Well, how do I need to put that in there? All right, so it's showing it here. So what I did wrong is I needed to put the year. I need to spell the year out correctly. So let's go ahead and fix that. So 2026, okay. Tab out of that. All right, I did something wrong with the date over here. This is invalid. I mean, the altitude's invalid. I put the cruising speed as the altitude, but I did it wrong anyway. I thought I was putting it in the right place. So cruising speed, we'll put in knots, followed by 4 digits. Okay, so let's say we're 100 knots. That'd be knots. So it'd be in 0-100. That'd be the cruising speed. Okay, altitude, you would not put 5,500 here. The way you put your altitude is if we're flying below 18,000 feet, it's going to be, my glasses on here. So it'd be 055, yeah. So it'd be A055 is what we put in there for 5,500 feet. So here we put A055. Okay. Now I should be okay to route brief. And now it'll come back and ask me some questions on how I want to set up this briefing. Now this is really kind of important on whether you get a briefing that's 20 pages long or a briefing that's 200 pages long. Okay? So your briefing corridor. So that was that corridor, that thing that we had there. You can set the briefing corridor. You can set the winds aloft corridor. There's things you can include in the briefing. There's content that you can have. there's different stuff that it looks for, and the more and whether you want it to come back in plain language or not. Obviously, if you bring it back in plain language, you're going to have a very long briefing, and the more of these things you check, the bigger your briefing is going to be. So we'll go through. I'll show you kind of what I typically do. So from a briefing corridor, I think 50 is the smallest you can get. Yeah, 50, 75, or 100. So we're going to go with 50. Winds aloft corridor, I believe 100 is the smallest you can get. It is. So we're going to leave that at 100. All right. Briefing output include graphics, include Nextrin content, plain text translation. I'd leave that usually off because that'll make it very, very long. Okay. Evaluate departure time details. Yes, I'll show you what. Well, I think this will show it. Yeah, it'll show it to you here. You'll see this when we get into it. But one of the first things that'll pop up is it'll say, okay, your planned departure time is this time. And during this time, these will be the conditions. But if you leave at this time, this will be your conditions at departure, en route, destination. So it'll show you, hey, here I got all VFR, so if I move my departure to here, my weather is better. So it gives you some idea of when a better departure time might be based on the forecast. So I usually will leave that on. Okay, briefing content. Let's see, only include most recent METARs. So the reason you might not want to do this is if you get older METARs, you get trend, and trend can be valuable, right? So if I get a METAR that says that the visibility, the temperature dew points, I don't know, let's say 2520, okay? But I look at the previous one, maybe the temperature dew point was 2519, 2518, and I see a trend that it's closing. That might, and I'm not planning to get there for another couple hours. By the time I get there, things may be different. Does that make sense? So maybe you want the trend, maybe you don't. Okay, for this purpose, I'm going to leave it off. Only include winds aloft for altitudes within 4,000 feet. Yeah, that's fine. Or I'm gonna leave that on. I don't need all of them. Only include en route obstruction NOTAMs above the field altitude minus 1,000 feet. Yeah, so in other words, I don't need, high, tall stuff that's way out all over the place. All right. Include en route nav NOTAMs. I'm going to just leave all of that off. Include FTC. I'm leaving all that off so we don't get a whole bunch of stuff. All right, now we can get three types of briefing. We can get a web briefing, a PDF briefing, or we can get an emailed briefing. So for purposes of this, I'm going to get a web briefing. We're going to click that. It's going to put the briefing together.
If you were to select the VOR, would it actually give you like VOR frequencies?
It'll give, no, that was NOTAMs for it. So it's going to give you NOTAM issues with VORs. So if you're planning on using VORs for navigation, I would click that. I'd turn that on. Your VFR frequencies are all on your chart stuff. Yeah. Okay. All right. So here's the briefing. I'm just going to quickly scroll down and show you how long this is. That's the briefing. And that was with most of it turned off.
I have no appreciation for commercial pilots.
Yeah. So that's that. Let's bring this back up. Let's bring this back up to the top here. We're going to go through each one of these. Okay. Over here on the left side is where I told you that where the table of contents is, right? And this is that stuff I showed you before in one of the first slides. So you have your overview, you have your adverse conditions, your synopsis, your forecast, your NOTAMs, all that kind of stuff. So these are all the things that are included. Temporary flight restrictions, synopsis, surface analysis, METARs, flight categories, ceilings, visibilities. You can go straight to one of them. If you want to go to winds, go boom, right there. There's your winds. You can click right to whatever it is you want to see. Synopsis, surface analysis, right there. So using that table of contents, if you will, on the left, you can zoom, you can click right to where you want to go. All right, so first off, flight plan summary. This is what we planned. So this is what we told it to do. So our type, that we're cruising at 100 knots at 5,500 feet. Time of departures, 12 Central Time. Departure airport, destination, route is direct, destination, so forth. Briefing customization. This is stuff we turned on and turned off. Okay? And then we get into this evaluate departure time details. So this doesn't look very interesting because the weather today is not that interesting. What this is showing us is that at the time of departure, it's VFR here, it's VFR everywhere in between, there's nothing there, and it's VFR there. So there's nothing wrong with our departure time. At the time of departure, there is a TFR somewhere near our departure. Okay, there are no closed run safe runways, there's nothing for segments, convective segments, nothing. There's nothing. Everything looks good today. Might be windy, but there's no weather related stuff going on today. So you can get right there a good indication that everything looks pretty good right off the bat. If there was bad stuff on there, it would show up on where it was. And you can see right here, the first thing that shows up is the temporary flight restriction. So here it says that there's some type of temporary flight restriction near the departure. Well, it's right there. There's a TFR right there. Now, it's not going to hinder us in any way, but it's right there in relationship to our departure. Okay. All right, we'll just kind of scroll down through this. This tells you what the TFR is. I'm not going to get into reading it because it doesn't apply to us in any way, so I don't care about it. There are no closed or unsafe NOTAMs to talk about. There are no convective segments, no G airments, no IFR airments, no obscuration airments, no icing. Here's your icing levels, freezing levels right there. And you can see that that one's at 16,000 feet. That's the one that would cover our route. And we're well below 16,000 feet, so we don't have to worry about that one at all. All right, come down here to urgent pilot reports, nothing. No center weather advisories. So now, this is a day where the weather's good, and this is how long this thing is. If it's a bad weather day, you got a lot of stuff going on. All right, here's your surface analysis chart. We looked at this before, so this gives you a big picture. And if you look down at where we're at, we really have nothing going on. Nothing happening here. All right, here's our route. And these are the facilities, the airports with which it gave us METARs or TAFs. So we get information. Remember, we need current and forecast information at departure, en route, and destination. So here's departure and destination, and these are the en route information that it's giving us, coming from those stations. Okay. And then it comes down and it gives us that information right there. So now you can go through and look at the METARs, and I mean, if you want to, it's all VFR, right? But you can read through each one of those METARs at those different stations, and you are briefing, you're getting the briefing for the airports along your route, okay? Now, you could do that on your own, right? I mean, you could draw a line on the chart and you could say, I'm going from New Braunfels to VCT, and you can look at the METAR at both places, and you could look at METARs at these airports along the route, and you can look at TAFs. And you're doing exactly what this is doing, right? So you're fulfilling your obligation under 91-103 by doing that, whether you do it this way, or whether you do it on your own, or whether you call someone and have them read it to you. Does that make sense? Okay. I'm not saying don't do it this way. I'm just pointing out, it just has to get done. You're responsible to look at this stuff. You're responsible to evaluate this stuff and make the go, no-go decision. Okay. All right, so let's take a break here. We're 11 o'clock. We'll take a break and we'll finish out the rest of this over the hour. Before I finish, I remembered something that I want to go back to the map for just a second. Then I'll come back to this. I didn't open this up before. I'm going to open it up now. I forgot to show you this, but towards the bottom of this, I left that closed. But if you open up graphical forecast for aviation right here, you have some other things that are kind of neat, especially ceilings, visibilities, and clouds and that kind of stuff that I forgot to show you. But go to ceiling in here. Well, why is it not showing up here? Let's see. Here we go. Let's go clouds. Okay. So with the clouds, this is showing you the cloud cover. It's showing you the cloud. In this case, you can get that's the cover. You can get tops and bottoms. So if we go to cloud bases, you can come down here and get an idea where the bases are around us here. So this is showing us the bases down in the dark area. So less than 3,000 down in this area. Cloud tops, click here. And you can see the tops are going to be up around probably 5,000, 6,000, something like that. So you can get some idea of where the clouds are, and you can put that in motion as well over Zulu time. It's like they're gone there. Gone, gone. Yeah, so they dissipate between 17 and 1800 Zulu. I forgot to show you that. I wanted to show it to you because when we get into the forecast or the briefing, it lays this out, and I wanted to show it to you here before I got to the briefing side. So you get cloud cover there, and winds, same thing. These give you the wind barbs. Let me turn off the clouds so it's not. Well, that's your speed. So you get the wind barbs there. And you can see each barb, if you remember, is 10 knots. A long barb is 10 knots. Short barb is 5 knots. Direction it's coming from, so it's out of the south at 25 knots right there. You get some idea of what the wind directions are. And again, you can move this and see what the winds are supposed to do as the day goes on. You can see what happens with the winds as the day goes on. Okay, so I just wanted to show you that because I forgot to show it to you before. It comes up on the, it'll come up also in the briefing, which we'll get to, but I wanted you to see it there first. Okay, let's move on to flight categories. Everything is VFR. There's no marginal or IFR or low IFR shown at 1600 Zulu, at 1700 Zulu, at 1800 Zulu, or at 1900 Zulu. Nothing there. Ceilings, no ceilings at any of those time periods. So a pretty boring map. Visibility. Visibility would be, if it were, under 5, it would be colored. So there's no color there, so we got greater than 5 miles visibility. So we got good visibility at 1600, 1700, 1800, 1900. So the visibilities are all good. All right, here's the cloud cover. So here you can see the different cloud at 1600, at 17. And this is indicating what we just saw before. I'm going to zoom out a little bit. What we saw before, in that at 1600 we had some clouds. At 1700 they started going away. 1800 they're gone. 1900 they're gone. So it's kind of showing the same thing. So skies become clear. All right, and then here's the cloud tops. Cloud tops in here are what, around 5,500 or so, 6,000 feet at 16, and then they go away. Clouds dissipate and go away over the time frame. Cloud bases, same thing. Precipitation, there's none. There's no precipitation for the time frame that we're in here. Thunder, nothing. It would show isolated, scattered, or numerous. Nothing there. Pretty benign day from a weather standpoint. All right, here's our wind barbs. So you can get an indication of what the wind is doing in the different time frames along the route. It is lightening a little bit as we go. It gets a little heavier here, a little stronger here, and then it starts to lighten up as the hours go on. Surface winds. Surface winds 16, 17, 1800, 19, 19 Zulu, and then here's our destination 16, 17, 18, and 1900 Zulu. Freezing levels, we got nothing that we need to worry about. No freezing levels. Aerodrome forecast, so here's the TAFs. Now, of all those reporting stations that it showed before, not all of them had TAFs. These are the only 3 that have TAFs. You got some marginal conditions at some of these later in the day, but nothing that's happening along our time frames that we're supposed to be there. So we don't have anything to worry about here. Okay. This is winds aloft. This is just the key showing you what the winds, if you saw it, that's what the winds would be. All right, here is, let me zoom in on this. So the one nice thing about putting our 5,500 feet in there and getting our winds aloft from here is that it interpolated it at 5,500 feet. So when you get the raw winds aloft data, it comes in 3,000 foot increments, 3,000, 6,000, 9,000, and so forth. We're going at 5,500 feet. So what we would have to have done is take the 6,000 foot, 3,000 foot winds and 6,000 foot winds and interpolate what it would be at 55. This does it for us, and it shows us 180 or
180
at 18, yeah, 18 degrees Celsius at our filed altitude. All right, then we have convective outlooks. We got nothing because we're over here. We got no convective outlets to worry about. So pretty much an overall good day, other than maybe a little bit windy. Might be a little windier than what you are comfortable with. Remember last week I said when it comes to weather, we typically talk about thunderstorms, obstructions to visibility, and that kind of stuff as flying related weather, and we don't think about winds. Winds can be an issue, so you got to look at that too. Just because it's not thunderstorming and rain and the visibilities aren't low, winds can be a problem. So you got to look at your personal limitations and the limitations of the airplane, and make sure you can handle the winds. Here's the obstructions within 10 nautical miles, and the nice thing they have is they in red, so you can go straight to it. You can see the sea level obstruction heights, and then you got the ground level obstruction heights, and you can see where they are relative to the airport. In this case, this would be KBAS. And those are far enough away where you should be well above these by the time you get anywhere near those obstructions. So none of these should have any effect on us whatsoever. And then we get down here to these obstructions down at Victoria. And again, you can see that these are sea level. Now we're closer to sea level here, obviously. So these are sea level elevations or altitudes. And again, those are far enough away from the airport that they shouldn't be a factor to us once we get there. Okay. Okay, en route NOTAMs. What do we got here? ZHU, full service route advisory and hold message above. So these are frequency changes for communications with center, with Houston Center. Nothing there that I'm worried about. Airspace stuff, not worried about any of this kind of stuff. What do we got here? Special use airspace. So these are the MOAs. There's nothing that's jumping out here at me that I'm worried about. And all of this stuff here, my gosh, FTC NOTAMs, Yeah, you're responsible to read all that. Have fun with that. Okay, there's your briefing. That's pretty long. That's a lot of information there on a good weather day, right? So, I'll tell you what I do, okay? If I'm in the system, if I'm flying IFR, if I'm on my IFR flight plan, I'm really paying attention to those NOTAMs that relate to comms and relate to navigation facilities that I'm going to be using. I'm really uber focused on that kind of stuff. If I'm flying in the VFR world, I want to look at it, but I'm not as worried about it. How many of you are using VORs to navigate nowadays? You really don't, right? VORs, using GPS most of the time to navigate. Doesn't mean you don't want to be cognizant that, you know, a particular VOR along your route's not working, because maybe you do, but it's not as important as perhaps your destination airport has a north-south and an east-west runway, and the winds are 20, 25 knots out of the north, and runway 1836 is closed. That's an important NOTAM. That one I'm more worried about. You know, does that make sense? So take these NOTAMs in the context of what you're doing, and get the information out of it that you need to get out of it. All right. All right, what's the best practice on learning how to self-brief? Well, my advice, let me turn this stuff off. My advice would be to start with this right here. Because this list right here, well, get this AC, read this AC, okay? Understand what products are out there that are available to you to look at that give you big picture information, and then how to drill down from there. Start with the big picture. Start with the major movement of systems. So from a chart standpoint, this chart right here would be a really important chart. That chart right there would be a really important chart to look at. Typically, if you're going to go fly someplace, some distance away, you're going to know that you want to fly there at least a day or so ahead of time, right? And so start watching this right here. Look at what the weather guys say the weather's going to do over time, over the next 48 hours. And get some idea of how that impacts your route of flight, if it impacts your route of flight. Okay, that's where I would start. As you get closer to it, now start looking at more local, start getting a little more granular. Look at your departure and your destination airports. Your departure specifically for the time frame that you want to, the forecast for the time that you want to depart. Obviously, if you're looking at it the day before, the METAR for the day before doesn't do you any good, right? But the TAF, the day before, you can look at the TAF. Look at the destination airport, the TAF for the arrival time, roughly, that you plan to get there. And then look at the same thing along with those airports along the route. Just start developing a picture of what the weather is likely to look like, okay? And then as you get closer, just get more refined with that. But understand, what products do you look at? You look at the METARs, you look at the TAFs, you look at the surface analysis charts, you look at the graphical forecast, you look at you go to the interactive map. Look at what's expected to be along your route, okay? Get a briefing, get a weather briefing, do what we just did, and actually get a briefing. Look through it and try and understand it as best you can, and then pick up the phone and call 1-800-WX-BRIEF and give them the same information and let them know, hey, I got a briefing off of 800-WX-BRIEF, I'm looking at it, I would like to go over it with you and have you help me with it. And they can put more meat on the bones for you, and you'll understand it a little bit better. And even if you don't say that, The fact that you've looked at it, as they're saying what they're saying, is going to have, there's going to be more meaningful information coming out of it because you've already seen it. And so you're more likely to pick up on what they're saying. And if at any time during that briefing you have a question, stop them and say, wait, what did you just say and what does that mean? Okay? And they'll be happy to give you that information. Does that make sense to you guys? Okay. I want to go for the next half hour that we have, I want to go through the process of filing a flight plan, activating the flight plan, and closing the flight plan with you. Okay, I want to go through that with you. Does anybody have any questions? I know this, there's so much here, and I went through it kind of fast, but do you have questions on what I went through? Okay. The best advice I have is to go here, or go to ForeFlight, or go whatever it is, wherever it is you're going to get this information, and start learning how to get this information, and start learning how to look at and interpret this information. Current information, forecast information. Start learning how to start getting comfortable with that. 91-103 says what? You must get a weather. You are responsible if you're making a flight from a weather standpoint. If you're making a flight outside the vicinity of the airport, in other words, you're not just in the pattern. You're going someplace, even out to the practice area. If you're going someplace other than flying around in circles at the airport, you're responsible to, here's the vague, check the weather. What does that mean? That means you're checking two things at three places. What two things are you checking? Current forecast at what three places?
Destination, origin, and route.
Right. That's what you're responsible to check. How do you check that? Well, you check current forecasts in those three places. What are current forecasts? Weather depiction charts, surface analysis charts, METARs. What are forecasted things? The prog charts, the TAFs, winds aloft. That's what you're checking. That's how you do it. Okay. All right. All right. When you get a briefing, once you get a briefing, you will have the option. Let me see if I still have it up here. You'll have an option to file a flight plan. Oh my gosh, come on. No, let's see. Right there. You could file it right there. So you could get the route, you could get a briefing, or you could not get a briefing. You could fill this information out and you could file it right there. You could click that button to file the flight plan. Once you file a flight plan, and you can do that whether you click VFR or IFR up here. If you're flying on an IFR flight plan, which right now nobody needs to worry about, but at some point if you get your instrument rating, then you would do this. You click IFR. Once you hit file, whether this says IFR or VFR depends on where it goes from there. If you click IFR, then that flight plan goes to ATC. ATC, Air Traffic Control. If you click VFR, that flight plan goes to FSS, Flight Service Station. If you file a VFR flight plan, and then you get out here, you start it, you get ready to leave, and you call Carl in the tower and say, Carl, I want to pick up my flight plan. He's going to say, what flight plan? I got a VFR flight plan. I don't know anything about VFR flight plans. He has no idea that you filed a VFR flight plan. If you file an IFR flight plan, he's going to know about it. Okay? So we're filing VFR flight plans. When you file it, In this case, we said we're leaving at 12 o'clock noon, which is 30 minutes from now. Okay? Once it's filed, it really means nothing unless you activate it. So that's the first thing to understand with flight plans. If you file a flight plan and you never activate the flight plan, VFR or IFR for that matter, an hour later that thing's going in the garbage. It's just, they're going to throw it away. It's going to be purged out of the system. So if you file a flight plan and you decide not to fly, don't worry about it. You don't have to call anybody. In an hour, that thing's just gone out of the system. But if you take off or you activate, not if you take off, if you activate the flight plan, now you must close that flight plan. If you don't close it, then a half hour after your proposed arrival time, they will start looking for you. Okay? So if you activate it, then it must be closed. If you never activate it, it's just going to get thrown away, so you don't have to worry about it. Does that make sense? Okay, so let's talk about how do you activate a flight plan. Filing it does not activate it. Filing it just says, I'm planning on making this flight. I'll let you know if I do. That's all you're saying. I'll let you know when to make it active or when to open it. Okay, so how do we do that? There's a number of ways to do that. You can, through this service right here, you can set up texts. You can go into your profile, you can set up texting. So once you have one on file, you'll have the option on your phone at the end of the runway before you take off to say, activate. And boom, you're activated. And then you can also close it that way from your phone when you get to where you want to go. Okay, that's one way of doing it. That's probably the best, easiest way of doing it. Is just do it through your phone, just text-based. You can just activate it right there. The other way you can do it, the old-fashioned way of doing it, was, let's see, here we go. Was after you take off was to call flight service, and the way that you call flight service is to find a frequency on a VOR box, like here's the VOR box at San Angelo or at San Antonio. So the San Antonio, this is the San Antonio VOR, and here's the information box. And when you see these VOR boxes, everything inside the box, anytime you see a VOR information block, everything inside that box has to do with the VOR. So the San Antonio VOR, the frequency, the channel if you're in a military airplane, SAT is the identifier, ... is S, ... is S, ... is A, dash is T. That's the Morse code for that. Everything inside the box deals with the VOR. Everything outside the box deals with the flight service station. So it's San Angelo Flight Service, and you can reach them on 122.3. So if you're anywhere flying around, anywhere, you don't have to be that close to the VOR. Anywhere where your radio could reach it, anywhere, you know, around here where you could conceivably talk to that VOR, if there was a guy there with a radio at that VOR, which there is, essentially there's a remote communications outlet right there, an RCO right there, that's relaying your communication to San Angelo, or actually to Washington. That's where it's being relayed to. Washington is where it's going. But you could pick them up, you could call 122.3 and you could activate it. So let's say that we depart, and let's say we use that, because we could, from New Braunfels, we could talk to 122.3 from New Braunfels. So we could take off out of New Braunfels and head southeast. And let's say we take off at 12:15. So we don't have to get off exactly at noon. We're just saying that's our planned departure time. And our en route time was what?
About 55 minutes.
Let's call it an hour, right? So an hour. So they would expect us to be landing then at 1300 or 1 o'clock local time, right? Well, let's say we took off at 12:30. Say we didn't get off the ground until 12:30. Okay. Well, if they started and then we activated, if they started our timing at 12, that means they're going to start looking for us at the same time that we land, 30 minutes later, right? So when we activate it, we have to do two things. We have to activate it, and we have to tell them when we actually left. We have to update our proposed departure time to an actual departure time so that the 55 minutes starts there and not at noon. Make sense? So when you text it, it's done. I'm leaving now, so the updated departure time is when you send the text. Okay? So it's pretty simple. But if you call them, you have to tell them that. So the call might be, and let's say you take off at 12:30, but you don't call them till 12:45. Okay? You would call them and you would say, and you could call them San Angelo Flight Service, or you could call them San Angelo Radio. We refer to flight service stations as radio. You say San Angelo Radio, 448 Romeo Alpha, and then just wait. Wait for them to get back to you. They're not ATC. So usually, my experience when I call flight service, I usually have to call them. I might have to call them a couple times. They don't typically get back like ATC does. You just wait. They'll get back to you. And then 448 Romeo Alpha, San Angelo Radio, go ahead. And then you would say, San Angelo Radio, 448 Romeo Alpha, like to activate my flight plan from KBAS to VCT, departed at 12:30 local. And then they know, we're going to update the departure time to 12:30 local. Okay. What if you take off at 12:45 and you forget to open it and you wait till 1:05 to call? They're going to say, we don't have a flight plan on file because it already got purged. Okay? That make sense? All right. So the key is, whatever your departure time, whatever your planned departure time is, you have 1 hour after that to activate it, or else it's going in the garbage. And whenever you do activate it, if it's still within that valid time period, that 1 hour period, when you do activate it, you have to tell them your departure time so that they, update they don't start looking for you until it's time to start looking for you. Okay. Now, closing the flight plan is really important. At 30 minutes, one of the reasons is you put your phone number and your information in that little box, that was down there where I had my information in there. And once you get things set up, your information should show up there automatically. The reason you want it there is because at that 30-minute point, the first thing they're going to do is try and contact you and say, "Hey, did you land?" "Yeah, okay. Well, we'll go ahead and close your flight plan for you before we start sending out the cavalry to look for you." So they're going to call you. If they can't reach you, they'll probably call the airport you flew to. If it was a towered airport, they maybe contact the tower and say, "Hey, did 448 Romeo Alpha, did it land? Is it on the ramp?" If it's not, if it's a non-towered airport, maybe they try and contact the FBO. "Hey, is this airport sitting out there on the ramp? Do you see that in number out there on the ramp somewhere?" They're going to try and do that before they, send out the cavalry, so to speak. But if they do have to send out people looking for you, guess who's getting the bill? Yeah, so don't forget to close your flight plan if you open one. Make sure you close it. Okay, let's see. Another thing I want to show you with respect to this, you could get a question like this on your practical exam. So here's San Angelo 122.2 there. There's another one down here. Let me find it. There's not too many of these around anymore, but they still exist. That's 122.6. I thought it was down there. And some VORs, like this one here, Syntex, there is no RCO. This VOR has no RCO. So there's no way to contact, there's no remote communications outlet. So this is simply navigation only.
Generally speaking, would you tend to do this once you're in the air or when you're on the ground before you taxi?
If you can reach them on the ground before you taxi, do it on the ground. But the chances, like for here, you're not going to get San Angelo from the ground here. Not on 122.3 anyway. You can call them on the phone. Yeah, you could do that too. Yeah, you could call them on your cell phone before you take off too. So you could say, hey, I'm departing in 5 minutes. Activate with a 5 minutes from now or something like that. Yeah, you could absolutely do that. What's that? Yeah, that's a pretty common thing. Yeah. And if it's IFR, then you just need to get a hold of ATC. ATC then opens and closes your. If it's IFR, you don't have to open or close. ATC does it. When they give you the clearance to depart, that opens it, and when they give you the clearance to land, that closes it. So you don't have to do anything. But if it's VFR, it's your responsibility. All right, so here's an example of one that I wanted to show you. Let me zoom in on that. Stonewall VOR. So this is the way most of them used to be back in the day. So here's the Stonewall VOR. So here's your Stonewall information. It's still San Angelo, but now you got 122.1R. So you still see a few of these around. And what this means is that the R means that they can only receive. So Stonewall can hear you on 122.1, but they can't talk back to you on 122.1. So it's a weird kind of thing that still exists. And there's quite a few of them out there. But thankfully for you guys, there's more of the two-way communications RCOs out there than these anymore. It used to be pretty much all these. And when you contact, if you do have to use one of these, then you have to have a navigation radio in your airplane. You have to have a radio that you can tune into a VOR. So in other words, you need a radio that you can get 113. A communications radio will not. You cannot dial 113.8 into a comm radio. That frequency band doesn't exist in a comm radio. Okay? So you have to have a nav radio with a different frequency band that you can get 113.8 in. All right, so if you have a nav radio, then you could do this. You put 122.1 on the comm radio, and you would call San Angelo radio, and they would hear you, but they know you're coming in over one of these receive-only frequencies, and they don't. Not only do they not know where you are in Texas, they don't know where you are in the United States. You could be anywhere in the United. You can fly down to Florida and you can find 122.1 R. You can go to Maine, you can find 122.1 R. So wherever there's a 122.1 R, it's just simply saying, okay, take this signal and send it to Washington State. So when they get that, they're waiting for you to say, where are you, so I can call you back. All right. Now what you would say is, San Angelo radio, well, by saying San Angelo, they kind of have an idea that at least you're in Texas. San Angelo radio, 448 Romeo Alpha, listening Stonewall, or listening 113.8. And then they'll call you back on that frequency. But what you have to do is you have to go to your navigation radio, put 113.8 in the navigation radio. In our aircraft, you got to go over up here. So we only have nav on radio 1. So you got to go to the nav side, put 113.8 in. Then you have to come up to the audio panel and turn on the volume to nav 1, or you won't hear anything. So turn the volume on, and then you'll hear them talking. You'll hear them talking over. In this case, you'll hear ... dash ... dash, and they'll be talking over that. ... dash ... and they'll be talking over that. Okay?
So for the San Antonio one, do you contact 116.8?
No, for the San Antonio one, you don't have to do it. San Antonio is a two-way.
It's 122.
122.3. Only if it has an R will they receive only. They receive, not your. The way to remember that is everything on the outside of this box, none of that deals with you. It all deals with them. So the R means they receive, not you receive only, they receive only. Just think about it that way. Your confusion, can't remember, well, do I hear on that or do they hear on that? Everything about what's on the outside of this has to do with this flight service facility. In this case, they hear you and you hear them on 122.3. But if it was 122.1R, then they hear you on 122.1R and they can't talk to you on it. So they receive. Make sense? So there's not too many places that I know of around here where you would find a 122.1R where you wouldn't also find another VOR close enough that you could get them on a two-way frequency. Okay. But if you found yourself in an odd situation like that and you needed to contact them and you have a nav radio, but you got to have a nav radio. If you don't have a nav radio, you can't dial that frequency in. Okay. And a lot of planes are going away from nav radios. Everybody's using GPS. So if all you have is a GPS, you can't tune into it. You can't do it. Okay. Any questions on that?
If you don't have a nav radio and you still call into VR, can you still technically activate your flight plan even though they can't respond back?
Well, I guess you could, sure, because they're going to hear you. The issue is you don't know when they hear you.
Right.
So you call them and maybe they're busy doing something. You rattle off everything and they didn't get it. They don't know how to call you back and say, repeat that. I was doing something else. So it's not the best way to do it.
No, I imagine calling is probably,
Yeah.
or texting's probably
Texting,
the
yeah.
best way to do it,
Yeah.
but just in case.
Yeah. Yeah. The other thing to do, and the other reason to use these frequencies along the route is for pilot reports. So as you're flying along, you can contact, and they'll tell you that too, by the way. When you activate your flight plan, they're going to say, okay, your flight plan's activated. Don't forget to close your flight plan. And they're going to say, every time I've called flight service, pilot reports are appreciated. They always say that. They always end with that. Pilot reports are appreciated. They want those pilot reports. They want that information. And so many pilots don't give it. They just don't give them. And there's no reason not to. Again, you don't have to give all of that stuff. Just give, hey, it's beautiful. It's smooth and beautiful. You put that on the pilot report. Everything's beautiful here at this altitude. Or whatever. Okay? All right. That is everything that I got, guys. So we're about 15 minutes early. Any questions? Anything you want to go back over? Any of the reports you want to go back over? No? Okay, next week is 4th of July. And I will probably not be in a state to be able to teach. So we're going to have class next week. That's not true. In about an hour from now next week, I won't be in a state to be able to teach.
You're going to that thing, right?
What thing?
What's it called? Where you go watch the flames?
No, I'm not going to Chicago. I'm staying here.
Oh.
You talking about Oshkosh?
You talked about it.
Oh, Oshkosh, that's the end of July.
Okay.
That's at the
I
end of,
remember.
that's the last week of July.
Are you
But
going
I'm not
there?
going, no. Sebastian's going. Yeah, I'm not going. No. I went every year for 33 years, and then the last 3 years I haven't been. Isn't that terrible? It's awful.
So you're talking about a bit of
Not 33 years. Like 27 years. But anyway. Okay, so the next class is in 2 weeks. And it is... So July 11th, it's in Oshkosh, Wisconsin.
Yeah,
Wisconsin.
Oshkosh, Bagash. Here, I'll show you right here where it's at. I'll show you right now where it's at. It's right here. Right there. Whitman Regional. Right there. And I camp right about here. Right about where that star is, that's where I camp. Right about there.
It's crazy watching some everything come into land.
Yeah.
They're like three planes all landing
Yep.
on the same runway at the same time.
Yep.
Why?
Well, you got three on the runway.
Yeah.
You got 3 on the taxiway and 3 on the parallel taxiway. So you got 9 airplanes landing at the same time, right by each other.
Thank you.
The lake, the water, kind of that same thing where they're going, it looked like they're all coming at each other, but they're landing on the lake, doing
Yeah.
like, I watched this video on YouTube, it's like, holy
Lake Washington out by Seattle is like that, or Lake Union, right up downtown. That's nuts.
Okay, so,
Especially boaters don't give a crap
Yeah.
about the landing area for seaplanes.
yeah. Well, see, the thing is, seaplanes, if it's a navigable waterway, then you can land on it. It's legal to land on. The boats don't think about that, but planes can come in and land on it.
That's crazy.
If
So,
you're ever in that area, I highly suggest taking the float plane ride from Seattle to San Juan.
okay, July 11th is airport operations. Would you guys like me to get Carl from the tower down here? I do that every once in a while. Let me do that. Huh? From the control tower? Yeah, I'll call him and see if he can do it. He comes in when, sometimes, I don't always do it during that class, but he comes in and spends about an hour talking about what they do and all that stuff. So I'll contact him and see if he can do that on the 11th.
I don't want me to have a chance.
Okay, yeah, all right. Okay, guys, we'll have a safe 4th. And we'll see you in a couple of weeks, if not sooner.